It is possible. Yes. Any questions here? Yes, correct. So what will happen right now is that I deleted the branch. The no, not really. Not every developer will create a feature folder. There will be one feature folder under which, let's say, you are a developer. You are creating a feature. You are saying then something like code push or something like this. Created. I am another developer. I'm coming here. I'm saying feature Suresh code revert. Do you see what is happening right now? Yes, only the particular branch will be deleted. If you delete both the branches here, the folder will also get deleted. So folder is a virtual thing out here. So if you look, yes, you cannot have empty folders in Git, especially here. You cannot have empty folders. You will at least need to have one branch to create a folder out there. So I'll just delete this one. So if I delete this particular branch and also delete this branch, folder will also get deleted automatically without me telling anything. These are virtual folders. These are not actual folders. It's just virtual folder for you to just understand, is it developed, is it feature, or what is it, what is it, and all and so on and so forth. Yes, any more questions here?
Sir, for example, I don't want 68 files at a time. So
Okay.
I want only few. So
Okay.
is there any option to select only few files, or I have to
uh,
push the all the files?
no, you don't have to. That's the reason you have something called staging, right? And in staging, I said stage everything. You don't have to do stage everything. You can stage individual, let's say, files out there, and then you can push them out. So for example, let's take let's say that is a good example out here. So let's go ahead and see if I have any other folder out here. Okay. Let's see. Okay, let's see, I have something called templates. Let's see if this is an empty folder. Yes, this is an empty folder, but yeah, let's see if I have something like that. Okay. Let me get a folder and let me also show you how it is done. Let's say some Azure icons, which has a lot of things out here. I'm copying this folder, pasting it out here inside this particular repository. So I place this, and now if you see, there are about 131 files that are ready to be changed, right? You don't have to stage everything. If you click on this, it will stage everything to be committed and then pushed. But if you click on individual files, right, which is stage changes, and etc., you'll be able to stage individual things out here and then go ahead and do all these things as such. So you can, let's say, do individual stage and then you can commit and you can push. That's the reason I would suggest to come via the Visual Studio out here.
In a single commit, I will get, or multiple commit?
If you again, if I click on this one and click on, let's say, multiple files out here to be staged and commit it out, in this single commit you will have only these two files. And you push this commit, you'll only be pushing these two files out here.
Okay.
Yes, any more questions, guys? Someone on online, sorry, offline had a question. Mm-hmm. Okay, final output. So firstly, before we discuss about final output, one thing that I want to discuss is this. You're a developer. You push the code. I am a developer. I'm pushing the code. All the code is sitting where? In the developer branch. My question to you is that, is this a code in a high level language or a low level language? High level language, which means that you wrote a code, but you did not build a code, because I am telling you not to build a code. If you build a code, it will take your own, let's say, flavor and all that stuff. I don't want you to build a code. What I will do, or what we will do, is that treat develop as a default branch, store all your code here, attach this particular develop branch to something called as a build pipeline. Let's put that in place right now. There will be something known as a build pipeline, which we'll go into. And this develop branch is attached to this particular pipeline out here. This pipeline will have multiple steps inside it. Like it's a .NET code. So you will have .NET build, .NET publish, .NET, let's say, restore and all these things out. You'll have multiple steps. This build pipeline at the end is going to give you something known as an finished product, meaning high level language to a low level language, which is your DLL, zeros and ones binaries, or in the terminology of Azure DevOps, we call this as an artifact. So build pipeline at the end will give you something called as an artifact out here. So you are a developer, you are committing your code into your branch. I am a DevOps engineer. I am creating this particular build pipeline for you, attaching it to the repository so that whenever you as a developer commit your code into the develop branch using a pull request, automatically this pipeline triggers, gives you something called as an artifact out here. If all this process is automated, this is called as a continuous integration pipeline, CI pipeline out here. Continuous integration process, which means you are a developer, you're committing, you're not doing anything. That's it. You're just going ahead, leaving your commit, approving your pull request, completing your pull request. After that, your code is here. It'll be picked up by someone called as a build pipeline that you will be creating as a DevOps engineer. That will give you the artifact. Now, my question is that artifact is there with you. What do you want to do with this artifact? Deploy. Where do you want to deploy it? Web app or a virtual machine or an EC2 instance, whatever is your destination. To deploy it, again, I'm now telling don't use your local machine. We will attach this artifact to something called as a release pipeline, a CD, continuous deployment, which will take your code and very simply release it on an Azure environment. In our case, since we're using Azure, I'm telling that this is an Azure environment. It can be AWS, it can be GCP, it can be on-premise, and so on and so forth. So this is an Azure environment for me, which is nothing but an Azure tenant, Azure subscription, then a resource group. Let's get a resource group out here, let's see. Or I'll just put a direct web app out here, okay? So the code is going to go inside the Azure environment. So now let's see. You are a developer, you are committing your code into the develop branch. As and when you commit the code, there is a build pipeline that is getting triggered. So that's the reason we are calling it as a continuous integration process. We'll talk about it much more, which will give you something called as an artifact. As and when you have the artifact, let's say generated, you have another pipeline getting triggered, taking all your artifact, deploying it onto or top of, let's say, a web app or a virtual machine or an EC2 instance or a GCP, let's say cloud and all that stuff. And if this is happening continuously without any human intervention, it's called a CD, continuous deployment. So the core of DevOps is do these two things out here: CI, CD. That's the reason whenever you talk to a HR about DevOps, they just say it is CI/CD, a process of CI/CD out here, continuous integration and continuous deployment or delivery out there, such. So this is the process what we go into, and this is the branch strategy that we, let's say, play around with. Yes, any questions still here? Before pushing, yes, they will have to. Yes, correct. Updated code is, let's say, going in to avoid merge conflict and etc. If there's a merge conflict, the developer will simply go ahead, pull the code again, make his changes, and then push the code sim back into the repository as such. Yes. Any questions still here? Anyone? Any questions still here? Mm-hmm. No. it has to be, again, it depends upon what you are pushing in. If let's say you're pushing in an ARM template or a Terraform or a PowerShell, it has to be a DevOps engineer who needs to review it, or it has to be a person who has a knowledge on all these things. If you're pushing a, it shouldn't be a DevOps engineer. The reason being, we as a DevOps engineer, we are not expected to have the coding knowledge. So usually the pull approver of that particular pull request will be the technical lead of a development team, or will be the project manager of that particular development team. Those will approve the code out there. Sorry, we don't need to. No, we don't need to. We don't, as a DevOps engineer, we are not expected to create the code. That's the reason I'm telling you, don't have to create the code using Visual Studio. Just download it and then you can, do this demo and all these things. See, one more thing that I want to, let's say, highlight here is this. When I am saying I'm releasing the code, I will release it on a web app which I can use for testing. Because until now, my code isn't tested. It's nowhere tested. I'm not doing any testing and all these things out. I cannot give the code directly to my client, meaning I cannot directly publish the code and tell the user to, let's say, download Android, let's say 9.0, and install it. No, I cannot do that. I will have to first publish my code on something that me as a developer can test it out, see whether it's working fine or not. That's the reason we publish the code, or we push the code in an incremental approach. Firstly, we push the code onto a web app called dev web app, which is for a team called development team, so that once they push the code, they'll be able to test it. And once that's done, we do something called as a code promotion using the release pipeline. Same release pipeline. We take the code, we deploy it into something known as QA. But QAs can come here. They can test this out, understand how the code is really behaving. If there are bugs, report it back to the development team so that the development team can again create a feature branch, fix that bug, raise a pull request, do a continuous integration, then go into development, then go into QA, then again QA does the testing, reports if there are any bugs. Again, this is okay. This is happening in the same day, happening in the same hour. So my developers and the QAs are working together right now. So you are a developer, you are committing the code, you engage a QA telling it, okay, fine, this is the code on QA. Can you test it out? QA will report back to you. If your code is not correct, you again take a feature, correct that particular code, understand what are the bugs, test it on your local system, put it in the branch, CI, CD into develop, test it here, then promote it to QA. Finally, we promote it to one more environment so that the operations team can also, let's say, be engaged, because that's also a team that I need to accommodate, right? Okay. That's also a team that I need to accommodate. That's where I'll have one more web app called as a stage web app, or a stage environment. We call these as environments out here. And we do a code promotion, same code, into develop, into QA, into staging, so that it's tested thrice. 3 times it is tested out here. Finally, you have a web app which is called production. And from staging, you promote the code into production out here. And as and when the code hits production, you will, as a user on your phone, get a notification that Android 9 is available. Do you want to download this out? Do you want to upload your, or do you want to update this out, and so on and so forth. Again, this happens in an incremental process, guys. Very importantly, we are delivering all this code in the form of sprints. So there is a definite life cycle that now I am telling that this is, let's say, a sprint, and in one sprint I'm telling there are 4 weeks, and I want to deliver a feature to the user by the end of the 4th week. So I will say 3 weeks of development, 1 or 3 weeks of development and testing, 1 week of release and support. Because after release, I also have to, let's say, do something called as support out here. So what I'll do is for 3 weeks, I will allow, or 3 weeks, for 3 weeks of my sprint, I will allow my developers to go ahead and, let's say, do commits onto the develop branch using a pull request. By the end of the third week, I'm now telling there are no developmental activities allowed. There is only release activity and support activity which is allowed right now if the code is going into production. Hear me out. So now I'm telling no developer is allowed to commit the code onto the develop branch by the end of a sprint. Now I'm telling I'll come here. I'll also lock my develop branch out here. No direct commits at all on the develop branch. What I'm going to do is I'm going to now introduce one more branch called as a release branch out here. The reason being, as an organization, if I just look at your branching structure, I need to understand where you are. Are you developing? Which kind of a sprint are you in? Are you developmental sprint or are you a release sprint out here? I'll say this is release 9.0 and I'll say create this out. Let me do one thing. Let me delete this out again. Again, when I'm creating this branch out, just observe, I'm creating out of that particular develop 9.0. So I'll say this is release version 9.0. Whatever code that is there in develop is now there in release. Also, I'll implement branch policies on release. Let's say same branch policy again. And I will also start protecting my release branches right now. Now, this is what happens. I have created a release branch. Let's say this is release version 9.0. And now let's see. Same code that was there in develop is in release. I'll now change the source branch out here for my pipeline. I will say it is not develop. It is, let's say, release out here. Whatever code is there in release, I'll take it into the build, produce the artifact, test it for one last time on develop QA stage, finally promote it into production out here in the fourth sprint, or in the, let's say, in the fourth week of that particular sprint. I'm promoting it out to production and I'm now telling version 9.0 is go live or version 9.0 is in production right now, which means you as a user will be able to download that particular Android version 9.0 out here as such, right? So you as a user will be able to download that particular Android 9.0 version, and as and when you as a user downloaded that particular version, you are able to see that the camera is not working or some kind of a feature is not working. Very common, let's say, thing out there. What do you do? Sorry, report feedback. Exactly. You do a report feedback, or you call to the customer care. You first approach to a team called a technical support team or a customer care team of, let's say, an organization. You don't directly give a call to the developer and say, you know what, your code is not working, right? You don't know that. You don't know who the developer is. Normally, a company doesn't tell who the developer really is. It just tells Google has developed this out. That's it. So you go to this particular technical team or technical support and you say that, you know what, I have an issue, and technical support team will, try to, let's say, tell that, okay, fine, restart your phone or clear their cache or, do that cookies and all that stuff. It's still not resolving. They will contact the development team because both of them are working for the same organization. They know that. And development is not just one person, it's a huge team out here. So between the technical support and the development team, there will be some kind of a ticketing system that the technical team will just tell you, you know what, I have opened a ticket with my development team. They'll be using something like ServiceNow or Jira or something like that, which is a ticketing tool. I'll say ServiceNow. These folks or these technical team will go and raise a ticketing or raise a ticket, and one of the developer will take the ticket and now start working on the release branch of the code, because the release branch has gone into production, right? And now again I cannot do a direct commit onto the release branch. I will have to create a branch on my local machine, raise a pull request into the release branch after fixing the issue, right? So what I'll do is that I'll raise a branch, and whatever branch that you create on a release branch is called as a hot fix branch. Whatever branch that you create from a develop, it's called a feature branch, because you're developing something, you're developing a feature. But right now you're fixing a feature that is already deployed. That's the reason this is called as a hotfix branch. So I create a hotfix, change the code, merge it back into the release, and delete my hotfix out here. This is also a short-lived branch. Once I fix it, I'll test that particular, let's say, feature called camera. Is it working in develop? Is it working in QA? Is it working in stage? Are we good? Then go ahead and release it onto production. Then the technical support takes a feedback from the user telling, is it okay? Is it working fine? Once the user says it's good, they will close this particular ticket, and that particular development will be closed. And this release will now be called as, let's say, 9.0.1. It's a fix that we have done. There will be multiple security patches if you observe for a software. You'll be telling it is not 9, it will be telling me something like 9.0.2, 9.0.3, or 9.0.2.3 or something like that. All these will be happening continuously in this cycle using some or the other DevOps practice out here, and using a particular branching strategy. Any organization is going to follow branch strategies, guys, and branching and merging strategy in Azure DevOps. Go here, it's telling adopt a Git branching strategy, and it is telling you why it is. Again, you have a feature, you have a main, you have a develop, and all these things. And these are the things that you can have. You can have features, you can have develop, you can have hotfix, you can have release, and then how do you review? It's now telling what kind of a best practice you need to follow while reviewing a pull request, while creating a branch. What is the practice that you need to follow? So what I want you all to do, go through this, understanding how an organization should, or how an organization will implement a branching policy, or will implement a branching strategy. And let me know if you can, or let me know if you, let's say, have any issues out here. Let's see, can we create a feature branch from develop branch in the portal? Do we need to check out in local? No, you can create a feature branch in the portal also. Like, it's optional, you want to create it on your local. I created it on a local because I am replicating a developer. That's the reason I created it on a local. But you can go ahead and create it on the portal as well, not a problem. Yes, any questions still here?
Hi, Kiran.
Just a second, I'm taking a question offline, come back to you. Okay, into the release folder, correct. So whatever data is there in develop, it comes into the release folder. Sorry, no need to pull. Like, we already created a branch. But one final thing that I want to say is that the user is now satisfied. So you have released the code that is there on the release branch, send it into production. User is saying it's good. One final thing you do, sorry, one final thing that you do is that we totally forgot about the main branch, right? You have a main branch, and I'm now telling the main branch should act as a backup. So finally, what I'll do is, once the code is in production, we'll raise a pull request from the release into main, from the release into the main branch. So you unlock the main branch for a short period. You can also unlock the branches also. Same thing. Click on those three dots. Click on unlock. It will get unlocked. Raise a pull request between the release and the main. Whenever the code goes into production, we do this so that you can have a backup strategy. Just in case something happens, you know code that was working is there in main branch. You can take the code. You can simply switch the branch in your build pipeline. In your build, you can simply switch it to, let's say, your main, then do a release onto production out there. You now know that this is a tested code. You can simply go ahead and deploy it back into production out there as such. Only yes, only the stable production code is stored in main. Only the stable. So whenever you release a new stable version, you update your main branch. Uh, Someone online had a question. I'm sorry.
Hi Kiran. When we really when we
I'm sorry, I didn't get your question. Can you come again,
uh,
please?
when you release our code and the release code will be deleted, you told me right.
No, hotfix code will be deleted, not release code. Release is a long-lived branch. It's hotfix that will get deleted. Release will be retained.
Okay, okay.
Okay, and what kind of a tickets we as DevOps engineers get? Good question. We as DevOps engineers get tickets like, you know what? I need a new app service. Can you change your template? Or there is some bug in your PowerShell script. Can you revise that? So we as DevOps engineers, we are not in direct touch with an end client, meaning we are not in direct touch with, let's say, a user who's using the application. We are in touch with developers. So whenever a developer is now telling, okay, fine, I need to do a hot fix, there are two things that you need to consider. One, the change can be a code change. Two, the change can be an infrastructure change. Something in infrastructure is causing the issue. Two things can happen, or both the things can happen simultaneously. Meaning infrastructure change and code change out here. So for infrastructure change, they'll again reach out to us internally telling that, you know what, we need an infrastructure change out here. Can you help us out? So we go ahead, use our ARM templates, deploy the infrastructure here, test it out, and then finally send it to production out there as such. So we as DevOps engineers, we act as more like a support team for our developers to create infrastructure, to create, let's say, multiple scripts depending upon the requirement out there, out of the client as such. Internal organization tickets mostly it is internal organization tickets for DevOps engineers as such. Yes, any more questions here? So this is the strategy that we'll be applying when we are, let's say, doing our classes. So from tomorrow, we'll start with build pipeline. What is a build mechanism and all these things? We'll go there into build. We'll understand this one. And of course, there are a few concepts in, let's say, the branching. We'll have to address it retrospectively once we do a build out there as such. Not really. That's what I was telling you. There are multiple branch policies we need to implement. This is one of the branch policies you implement. When you come, you can come back. We can implement multiple things out here. So we'll be doing it parallelly. Okay, let's see how much time they would give to resolve a ticket. Depends upon the amount of complexity in a ticket. If it's very urgent, you'll have to fix it, let's say, on priority. If you have time, then you can, let's say, take some time, understand, do some, let's say, research on this, and then go ahead and, let's say, resolve that out. Depends upon the complexity of the issue. The ticket will also, let's say, give you time, or they won't give you time sometimes, stuff like that. Okay, thank you guys. We'll meet tomorrow and we'll start with a build and then we'll add multiple things. Srinath, I am a little out of time right now. Please park your question. I'll take it tomorrow. Thank you.